I procrastinate the same, both. I don't procrastinate when creativity has hit me. Otherwise, I drag my feet. And it's 11. So let's get started. Hopefully you don't hear the noise from outside as much. Yes, let's get this going. Okay. We are in module number 2. This is actually going to be more of a review if you have done something like CIS 71 or equivalent, like computer repair, or have taken the CompTIA A+. A strong foundation in OS is an important building block in becoming an effective forensic investigator. Just like your standard forensic investigator who handles physical crimes and has to look at bodies, or someone who does an autopsy, they have to be familiar with the human body. Forensics investigators, for everything digital, has to be well versed in how computers work. The evidence that investigators work with are all files. The organization of these files, the data they contain, and their locations will vary according to the OS and associated file systems that exist. As a reminder, a file system is a hierarchy of files and their respective directories. This module will be short and will focus on the file system supported by Microsoft. An investigator should understand allocated storage space and unallocated file space, along with a partition. The area that files are stored, the area where is open for more files to be written, and the logical storage units on a disk. So again, as a reminder, a byte is 8 bits and is the smallest addressable unit in memory. A sector on a magnetic disk represents 512 bytes, or 2048 bytes on an optical disk. There are newer disks that have sector sizes of 4096 bytes. A bad sector is an area of disk that can no longer be used to store data. Could be caused by viruses, could be caused by corrupted boot records, physical disruptions, etc., or even wear and tear. A cluster is a logical storage unit on a disk that contains contiguous sectors. When a disk is partitioned, the number of sectors in a cluster is defined. They could have 1, or 512K, or 128 sectors. These tracks are thin, concentric bands on a disk that consist of sectors where data is stored. Because most files are comprised of 512 byte blocks, it is important to understand that an 800 byte file would use 2 sectors and have file slack, or unused bytes in the last sector of a file. In this example, the physical size of the file is 1024 bytes, or 2 sectors, but the logical size is 800 bytes. Investigators typically spend their time examining hard disks. A platter is a circular disk made of aluminum, ceramic, or glass that stores data magnetically. The spindle is at the center of the disk, powered by a motor that is used to spin the platters, allowing actuator arms that have read-write heads to modify the magnetization of the disk when writing. They typically have 2 heads for each platter since data is written on both sides. Since these heads are nanometers from the platter, they must be handled very carefully and prevent any magnetic device, such as cell phones, microwaves, magnetic screwdrivers, near those platters. Yes. The difference of the logical and the physical is the size and the size on disk properties. A cylinder is the same track number on each platter, spanning all platters on a drive. This geometry refers to the structure of hard disk in terms of platters, tracks, and sectors. And the way that that's normally calculated is the number of cylinders times the number of heads times the number of sectors times the number of bytes per sector. Virtual memory is a feature of most operating systems. The page file is an area on a hard disk that stores an image of the random access memory, stored normally on pagefile.sys. That will store frames of data that have been swapped from RAM to the hard disk in order to allow running applications enough room to utilize RAM if it runs low on space. RAM, pagefile.sys, or any virtual memory is invaluable to investigators since it contains information about running processes, passwords, and web browsing artifacts. Investigators need to be able to convert between different numbering formats due to the way software displays data. Some files on a computer are in binary format and will need to be converted. It is also good to understand how to convert hexadecimal to ASCII. I have a lab assignment that'll give you hands-on experience if you have not done that before. If you have, it will be review. But that comes useful. Oh, I have my slides wrong. When covering things like file types and understanding the file types as showing it as hexadecimal. This slide is about the Windows file system, but there's a little bit of text before it. So in the realm of the operating system, we have the boot process. The kernel is at the core of an operating system and is responsible for communication between software and hardware. When a computer is powered on, the computer executes code stored in ROM, referred to the BIOS, which initializes system devices. Bootstrapping is the process of running a small piece of code to activate other parts of the operating system during the boot process. In modern computers, the Unified Extensible Firmware Interface has replaced BIOS and does the same job. In many examinations, the hard drive is removed to be imaged or cloned. It is important to also document information about the system and its specifications. In the master boot record is the first sector on a hard disk, sector 0, which is involved in the boot process and stores information about the partitions on a disk, including how many exist and their locations. The MBR is composed of the master partition table, the master boot code, the disk signature, and the end of sector marker. Now Windows, getting to this slide, has 5 file systems: FAT12, 16, 32, 64, and NTFS. FAT, or the file allocation table, uses a table, as the name implies, to store information about where files are stored, file space is available, and where files cannot be stored. NTFS, the new technology file system, replaced FAT, and we've been on NTFS for quite a long time. The reason why we have FAT12 that was introduced in 1980 is because it is still used. So just because it's old doesn't mean it's no longer in use. I mean, we still create programs in COBOL. FAT12 has been used in floppies and is universally supported by modern operating systems. FAT16 was the 16-bit file system for MS-DOS, with a file name limit to 8 characters, file extension to 3, and disk partition maximum size of 2 gigabytes. FAT32 is the 32-bit version, handling the maximum file sizes of 4 gigabytes. This is why if you get a USB drive from like Best Buy and it is 32 or 32 gigabytes, but you try to put a file that's bigger than 4 gigabytes, it fails because FAT32 only supports files up to 4 gigabytes each. FAT64, or also known as exFAT, can be recognized by Mac OS, but it doesn't really possess security or journaling features found in other OSs. The entire FAT family doesn't have any way to keep records of changes made to files in a journal. NTFS brought things like file compression, access control lists, and update sequence numbers that record things like the time of change, the reason for change, the file directory name, and the attributes, the master file table record number, file record number of the file's parent directory, security IDs, update sequence number, and information about the source of the change. The change journal is in $extend and in the folder $USR-JRNL, and the actual journal entries are retrievable from an alternate data stream, otherwise known as ADS. Alternate data stream is a file set of attributes, allowing files to have multiple data streams that can be viewed only by accessing the master file table. For example, while File Explorer will show details about a music's file logical path in a file system, VLC might use an additional data stream to update album information or associate the music file with other music of the same artist. Hackers can also hide data using ADS. So as I said, the master file table maintains file and folder metadata, including the file name, the creation date, the location, the size, permissions, compression, encryption, deletion, and free space to be reallocated for every file and folder. The default size for each entry is 1024 bytes. The header is 42 bytes, and the remaining for attributes. And those could be resident, content stored in the MFT record, or non-resident, stored in external clusters. The timestamp in the metadata or the MFT can be manipulated. It is advised to compare two MFT timestamps, the standard information or SIA and file name attribute, the FNA. While the standard information can be altered, the file name attribute cannot. Here is a list of the various files used that comprise the master file table. All important files when we're looking at, when we're doing investigations on an NTFS partition. Prefetch files, or .pf files, increase an application's performance. They contain information like when it was created, the run count, and any files or folders associated with the executable. These files contain timestamps like the last run, volume creation time. From Windows 8 forward, Prefetch has 8 timestamps according to the last run times. They are all stored in the root drive Windows Prefetch. And there's a long registry key that associates with it. Superfetch files, introduced in Vista, work with Memory Manager service to increase performance. Superfetch data is collected by the service host or SVC host and is located in root system32 sysmain.dll. The files are stored in prefetch directory with prefixes AG and extension DB, like this bottom one right here. Shell bags provides user viewing preferences for File Explorer. We can see users' sizing and position of a folder window, track when folders were viewed by a user, etc. The data resides in the registry at HK users, the user ID software Microsoft Windows shell, or shell no roam. The shim cache contains a record of executed binaries and which have been viewed in Explorer.exe but not executed. In XP, there was a maximum of 96 entries kept. In Windows 7, the max was 1,024. File metadata stored can also include full file path, file size, process execution flag, last update time, and last modified time. FireEye has an application called the shim cache parser that you can use to obtain this information that I'm talking about and export it in a CSV file. As you can see, Windows stores a lot of information that it would be useful in an investigation to show that a criminal was opening a program or had opened the same profile or same program X amount of times, went to X site, did X, Y, and Z, because it was all in Prefetch, or you could see the pattern of when the program was opened, when the file was opened, etc., to help build that information. Lastly, we have the Windows Registry. The registry is a hierarchical database that stores system configuration information. It maintains files used to control the operating system hardware, software, and keep track of users. In terms of evidence, registry can provide internet searches, sites visited, passwords, and user activity. Now, a word of caution. Changes to the registry may cause serious problems to Windows. Think of the registry as the soft underbelly of Windows. There are 5 major hives, as they call them. HK classes root contains file name extension associations like .exe, JPEG, zip, and so on. That is where Windows knows what program to use to open what file name extension. Also contained in this hive are COM objects, visual basic programs, and other automations. The component object model, or COM, allows non-programmers to write scripts for managing Windows operating system. The next one is HK current user. Contains the user profile for the current profile that is logged into the system when viewed. This will change every time a new user logs in. A user profile contains the desktop settings, network connections, printers, and personal groups. This hive contains very little data, but acts as a pointer to HK users. HK local machine contains information about a system setting, including information about the computer's hardware and operating system. The next one down is HK users. That contains information about all of the registered users on a system. Within this hive are a minimum of 3 keys. The first one is default, which contains a profile when no users are logged in. There's also a key containing the SID for the current local user, which normally starts with S1518. There's also a key for the current user with underscore classes at the end. And lastly, HK current config contains information pertaining to the system's hardware that is necessary during the startup process. Within this hive are the screen settings, screen resolution, and fonts. Information about plug and play BIOS is also found here. The Windows Registry is a total treasure trove of information that when you are doing your forensics investigations on Windows, be sure to grab that information. Now, there have been various features that have been added to Windows since its inception. There is a list of stuff from Vista up to 10. Some of the ones that are more notable for our usage. For example, in Vista, automatic defragmentation. That can give investigators a significant decrease in evidentiary data due to the nature of moving file chunks from one place on a drive to another. Ready Boost. Any data stored in that USB drive will be encrypted and should be captured on the live system when it's unencrypted. Volume shadow copy service is useful since there will be two types of shadow copy existing. You'll have the complete copy or the clone of the volume and copies only of the changes to the volume. Also, Vista brought in hyperfill.sys, which contains the content of RAM during hibernation. So if you have to investigate a machine that is hibernating, a Windows machine that is hibernating, you want to grab everything in RAM, and to do that, you would need to copy hyperfill.sys. Windows 7 gave us a number of things to either look out for or add. For example, there's biometrics. There's the jump list that lets you see recently accessed files and actions. The backup and restore center, which could provide file and image backups. BitLocker to go, again, making sure that it is on in order to read. Windows 7 actually has a timestamp and metadata of USB devices attached in Registry. So you can establish ownership of a USB device with Windows 7. Windows 7 brought touchscreen. If the device has a touchscreen, you could dust for fingerprints. Sticky notes, another place that people could save information. There are a couple of more interesting registry hive files that you'll need. The event viewer got a makeover that became more useful. File grouping definitely helps place files together regardless of where they actually are on a disk. It allows for faster searching for both the suspect and the investigator. Federated search. Libraries can be accessed based on different metadata criteria within files. You would examine an OSDX file to find out what has been already indexed by Windows. Let's see, Windows 10 brought in notifications that are saved in a file called apt.dat. The Edge browser saves web browsing artifacts in Web Cache v01. Cortana has a lot of information if used, and so on. Any questions? Okay. Make a video of that. And then we'll talk about the work for this week. Cool. Hit save to that. Upload this. CIS 77 module 2 lecture. $77, not for kids. Excellent. So now I can get rid of these files and we can talk about what we have on our to-do list. So let's do a new share. And hit record. Okay, so this week we have 3 things to do. Number 1, you have the review quiz, as you will for all your modules. You'll play the binary games and complete the challenges. Now, I suggest to record the answers, and then when you have them all, take the quiz where you're just really going to submit the answers. So the 4 things all of these, the H101, H102, 103, 104, 5, 6, and 7. I think I only put, I put them all here. So knock yourself out through all these. When you have all the flags, then go ahead and take the quiz. That way you have all the answers done and you'll knock it out in just in less than 5 minutes. So please don't take this ahead of time. Knock out this, then go ahead and do this. Lastly, or second to last, if you have a Windows machine, take a look at a lot of the stuff that we mentioned, like the registry, the files, like the page file, hyperfill, all that kind of stuff. Take a look and see what you find within them. If you don't have a native Windows machine, then create one on GCP. Use it for a bit and then look at what data gets added, what information is Windows storing about your usage. This is really it's really a exploration into what Windows is doing. But you could be quite surprised to see the amount of information it's storing about you. Now, lastly, if you don't have GCP credit, let me know, because I have the credit codes now and I can start distributing them out to all students. So I should have enough for everybody, but please contact me. The sooner the better to get your GCP codes so that you can create Windows VMs and use the full functionality of Google. Are there any questions? Looking at all 3 chats. Cool. Then I will stop the share and stream.